In the second part of the lesson, we will use Boolean operations and deal with user coordinate systems, abbreviated as UCS. Boolean, or as they are also called, logical operations are used for union, subtraction, or creating an intersection of 3D objects. Let's create several 3D objects, for example, box and cylinder. Select the Shaded with Edges display mode. If we have several 3D objects, as we can see, the created objects are currently independent of each other, and for the program do not have physical points of contact or intersection. Boolean operations are used to define interaction between them. With their help, we can combine these bodies into one. Use the union command and select both bodies. Press Enter. As we see, edges have appeared. Now it's one body in the history of 3D constructions. Undo the changes through Ctrl-Z and try the next operation, subtraction. First, click on the object from which we will subtract, then on the body, which we will subtract, that's the cylinder, and see the result of our subtracting actions. Also, roll back the changes and try our third command, intersection. Select both objects, and as a result, we get the creation of the intersection area between these two bodies. As I mentioned earlier, by default, new objects are created in the XY plane. For example, if we create a box, it is extruded in the XY plane. This can be changed if necessary by going to the View tab in the Coordinates group. Let's create a new UCS, that is, a user coordinate system. We will define it using 3 points. Let's turn off the unnecessary 3D snaps so they don't get in our way. First, we select the 0 point of the coordinate system. As we can see, the coordinate system has moved. Now we define the x-axis, the y-axis, and the z-axis will be constructed automatically. Now, if we create any object, it will be created in the new coordinate system. Let's undo the changes. The created UCS can be rotated around the desired axis. To do this, we'll use the UCS by command. Select the axis, let's say, the x-axis, and set the angle parameter to which we plan to rotate, for example, 180 degrees. As we can see, the direction of the axis has changed according to the set angle. You can also set the UCS relative to the selected view. Choose the front view. If we start drawing any sketch, we will not see it because it is created in the XY plane perpendicular to our view. To avoid this, we move to the View tab. Select the UCS by View command. Now our axes are redefined, and if we start to draw something, it will now be in a plane parallel to our screen. Press Escape. To return to the global coordinate system in the View tab, you need to select World, or click on the Clear UCS button. After that, the coordinate system will change back to the default one. There is also a feature for automatically determining the optimal plane for construction. It's called Dynamic UCS and can be enabled in the lower right corner. Enable Dynamic UCS. Now the program will highlight the planes for construction. If we go into 3D Tools, click the cursor on the 3D box, and now the program will highlight the plane on which our object will be created. Let's create a new object. As we can see, it is created exactly on the highlighted plane. Let's create another one. Let's say, a cone on another plane. Specify the radius, the height, and the cone is ready. As we can see, construction now takes place on the highlighted face with a redefinition of UCS for the created body. Now let's together do a simple reinforcing exercise. Create a cube with a side of 100 millimeters. In the command line, select the Cube option. Hold Shift for orthogonality of constructions and specify the side length of 100 millimeters. Enable isometry and shaded with edges display mode of the model. Next, create a sphere at one of the cube's vertices. Suppose on top. Specify the sphere's radius as 60. Use the intersection Boolean operation. Select both of our bodies and press Enter. Use the offset edge command, after which select the top face of the body and in the command line select the distance option. Enter 5 millimeters, press Enter, and click inside the contour to determine the side of the offset. Use the press pull command and extrude the obtained contour upwards by 30 millimeters. We get an interesting 3D object. This concludes the lesson dedicated to direct modeling. In the next lesson, we will learn to use parametric modeling. When you're ready, proceed to the next lesson. Thank you for your attention.